Okay, let's solve this system of equations using substitution method. So our objective again is we're going to solve for the coordinate point that lies on both of these lines. If you guys look at this, you should see that both of these are lines. So we could graph this out and see where they intersect, but this method that we're doing today is an algebraic method, so we're just going to solve these equations. Okay, so let's go through and we'll write the steps down as we go. So step one is going to be to isolate a variable. We're going to isolate a variable in one of the equations. Well, if you look at this equation, both of these equations right here, we can see that, well, in the first one we have the y, it's already isolated. So second one we also have the y is isolated. So I don't have to do step one for this equation, but it's important to know that that would be the first step. Okay, let's look at step two. Step two is, this is why it's called substitution method. We're going to substitute, let me type this, we're going to substitute the expression that you get for your isolated variable into the other equation. And this may seem like a confusing statement right here, but let's explain that. So let's color code this. So let's say that right here I have y is equal to green, 2x plus 7. Well, since I know that y is equal to 2x plus 7, and that y is also equal to negative 2x minus 5, well, I'm going to take this expression, and remember an expression is a combination of terms with an addition or subtraction sign. So here's a term and here's a term, so this is an expression. And since y is equal to this and y is equal to that, let's come down here and we're going to write my 2x plus 7, which is that y. And we're going to keep everything else, so we're going to say that's equal to this negative 2x minus 5. Oops. 2x minus 5. Okay, now what I get here is I get an equation. So this is one equation with one unknown. I only have an x variable here. So whenever I have one equation with just one variable, one unknown, I can solve for that variable. So let's go ahead and solve. So I'll put the scaffolding on this one. Let's isolate the x's over here. So I'm going to subtract 7 from both sides. And we'll do two steps at once. So I'm going to subtract 7 from both sides. And I want the 2x to come over here, so I'm going to add 2x to both sides. And now let's write this step down. 2x plus 2x is 4x. 7 minus 7, well, that goes away because I want to get it on this side. The negative 2x plus 2x, again, that goes away. And I have negative 5 minus 7, which is a negative 12. Okay, so now I have 4x is equal to negative 12. So I can solve for x, and again, I'll just do the scaffolding really quick. And I divide both sides by 4, and I get that x is equal to negative 3. So we can put this down as step 4, or step 3, sorry. So step 3, that was solve. So we're solve for your variable using algebra techniques. Okay, we have that, and now that we know what x is, well, my objective is I need to solve for x and y. So I can pick any one of these equations and I can solve for that. So let's do that now. We have that x is equal to -3. Well, let's just pick one of these equations, and I'm going to pick the top one. Come down here, and I'm going to use the fact that x is equal to -3 right here, and I'm going to solve for my y. So I have y is equal to 2, I'm going to put a parenthesis right here for right now, plus 7. So notice this is y is equal to, this is the equation from up top, y is equal to 2x plus 7. However, I know that my x is equal to -3. So what I'm going to do is, instead of putting an x there, I'm going to put in a -3 here, and I'm going to solve. So that gives me y is equal to -6 plus 7. So my y is equal to 1. So therefore I get y is equal to 1. So I get this point for my solution. We can write it in point form, and we get -3, 1 as my solution. So x is equal to -3 and y is equal to 1. Well, the last step now. Let's go through and check our answer. Let me write this down as a step 4 though. So step 4. And that was substitute answer you get from above step into either equation and solve for other variable. And then the last step, and remember this is always the last step for any solutions that you get. Let me group this. Is to always check your answer. So let's go through and let's check this. Step 5, one of the most important steps. So step 5, this is check your answer. Now after you get good at this, it's okay to check your answer in your head by substituting in, but let's go through and let's check our answer by plugging it in. So I'll do this one in purple. Okay, let's take the first equation. So this first equation will come down here, and instead of y, we're going to say our 1, because our y is 1, is equal to 2 times -3 plus 7. And I got the -3 because that's my x. So that's y is equal to 2x plus 7. But I'm using the value I found here. So let's simplify that. And I get -6 plus 7. Well, 1 is equal to 1. That checks out. So that works. Let's try it with this one. So again, 1 is equal to -2, and my x is -3 minus 5. Okay, well I get 1 is equal to, that's 6 minus 5, which again 1 is equal to 1. So both of these check out, which is great. That's what I wanted to happen. So I'm happy. Okay, so we have all of these steps. Let's organize this, and we'll use this for our next slide too. So let's copy this. Alright, let's do a more difficult problem. So if we look at this problem, we'll bring our steps over here, put them on the side. So step 1 is we're going to isolate a variable in one of the equations. Well, if we look here, we have both of these equations, and this should pop out right here. We have this x, which will be the easiest to isolate, so we can do that with just one step. So let's bring this equation down and isolate the x. I'm going to do that by adding 8y to both sides. So this equation becomes x is equal to, well, if I add 8y to both sides, I get a positive 8y minus 20. So I know what x is. X is equal to positive 8y minus 20. Well, let's write this equation down here with the blue parenthesis for the y. With the blue parenthesis for the x, because I solved for x. So let's come down and write 4, I'll put the blue parenthesis in here, minus 2y is equal to negative 20. So we're on to step 2. Substitute the expression that you get for your isolated variable into the other equation. You'll notice that this is 4x minus 2y. This is from my first equation right here. 4x minus 2y is equal to negative 20. But from this equation, I said that x is equal to 8y minus 20. So what I'm going to do here, instead of saying that x, I'm going to plug in this 8y minus 20. Let me clone that. Shrink it up a bit. Okay, so instead of 4x, I have 4 times 8y minus 20, and the reason we do that is because that gives us an equation with only y's in it, so only one variable, which means I can solve for that variable. So let's go through and we'll distribute the 4 first. We'll come out here and solve for our y. So that gives me 8 times 4, 32y minus 80 minus 2y is equal to negative 20. I'm going to combine like terms. My like terms here are 32y and a negative 2y, and I'm also going to add 80 to both sides. When I do that, 32y minus 2y gives me 30y. And when I add 80 to both sides, well, 80 minus 20 is 60. Divide both sides by 30, and I get y is equal to 2. Okay, so I got all that to solve for my y equal to 2. So I'm halfway there. Alright. So now that I know y is equal to 2, that was solving step 3, was finding out y is equal to 2. Step 4 now, so I'm going to substitute my answer into either one of the equations to solve for x. Well, note that this equation is already isolated for x, so this is the easiest one right here to use. I'm going to use this equation, and you'll see why when I come down here and plug in x is equal to 8, put a parenthesis for my y, minus 20, and I know that y is equal to 2, so let's plug that in right here and solve. Therefore my x is equal to 8 times 2 is 16 minus 20, which that equals negative 4. Alright, so my coordinate point here is x is negative 4, y is 2. Now we can come through and substitute those in, and let's do this step 5. Let's do the checking step and our head. So let's plug this in, and we can say, write a small negative 4 for an x and a small 2 for a y. So if I had, this is my x, this is my y, let's do this in our head. 4 times negative 4 is negative 16. Negative 2 times 2 is negative 4. Negative 16 minus 4 is equal to negative 20. So that checks out. That's good. And let's do that down here. Now we can use either one of these equations. Let's do it in the original one. So there's an x. There's my y. So we have x is negative 4. So negative 4 there. Negative 4 minus, and 8 times 2 is 16. Negative 4 minus 16 is equal to negative 20. So both of these check out. So therefore 4, 2 is my answer. So that's good. Okay, let's do one more example. And we'll do this one quickly. If you can't follow along on this one, or if I go too fast, then you can always stop the video and make it go slower. Alright, this one, step 1 is a little bit trickier. Isolating a variable in one of the equations because none of them are by themselves. So there's no equation that's by themselves, or no variable that is doesn't have a coefficient. So I'm just going to pick one, and it's pretty arbitrary which one you pick. So I'm going to pick this bottom one. So let's rearrange this bottom equation. I'm going to add 8y to both sides, so I get 8y minus 12. Now I'm going to isolate x by dividing everything by 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. So now I've isolated my x variable, so step 1 is done. Now I'm on to step 2. Substitute that variable into the other equation. So I'll put this in red. I'll have it right here. I'm going to write the other equation down here. So negative 6, put red parentheses, plus 8y is equal to 18. Well, this is negative 6x from here, but instead of that, I'm going to substitute in the expression that you get from the isolated variable into the other equation. So the expression is this, the 2y minus 3. And now I'm going to go through my algebraic techniques to solve for this. So that's negative 12y plus 18 plus 8y is equal to 18. Now I'm going to combine my y's, so negative 12y plus 8y gives me a negative 4y. And I'm going to subtract my 18 from both sides, so 18 minus 18 is 0. Now I'm going to divide by negative 4, so that gives me y is equal to 0 divided by negative 4, which 0 divided by any number is equal to 0. A lot of people get mixed up here and they say no solution, but that's only if the 0 is on the bottom. Since the 0 is on top, we're fine. And we get our answer is 0. Okay, so step 3 is done. Step 4, substitute the answer you get into the above equation into any one of the other ones. So if we have y is equal to 0, let's substitute that in, and let's substitute that in right here for this y and solve for x. We'll do this in a different color, we'll do it in green. So we'll say x is equal to 2, and now instead of y we're substituting in the 0 minus 3, therefore my x is equal to 0 minus 3, which is equal to negative 3. So I get my point as being, for x, negative 3, for my y, 0. So let's take that and plug these values in up here. So my x, oops, got a negative. My x is negative 3 and my y is 0, so let's plug those in here and here. Negative 6 times negative 3 is a positive 18. Positive 18, and then that's 0 is equal to 18, so that's correct. So we have that one. And if we come down here, we have negative 3. 4 times negative 3 is a negative 12. Negative 12 minus 0 is equal to negative 12. Again, we have this correct. So we are good. Okay, so make sure that in your notes you have these steps down, that you understand the wording behind all of them. All of these are very important, but it's about understanding what each one of these statements represents in solving my systems of equations.